right, so we're going to continue our discussion on logs and exponentials. We can use the properties of logarithmic form and exponential form to solve certain equations. So if I have this first one, I have 10 to the x power is 325. I have no idea what exactly 10 to some power is going to be that gives me this, because 10 squared is 100, but 10 to the third is 1,000. So this is not going to be an exact answer. But that's where logarithms come in handy, because it can find us the value that would make this equal to 325. So if I convert to a logarithmic form, I'd have log base 10 of 325. Now I didn't write a base 10 because that's a common log, so I can keep it that way. And so it should equal what was the input, x. And there's a way for us to figure out what that would be. But this is the exact answer, log of 325. If we needed to approximate that, we have a log button on our calculator. So we find the log button, and if I press it once, I get the natural log. If I press it twice, I get the regular log. So log of 325. I can close that off, and it would tell me it would be about 2.51 and keep going on forever. So not every log is going to give you an exact answer, but now I know that x is exactly log of 325. If I needed to approximate that to figure out in context of a word problem, that would be like 2.5 something. And number 2, I'm going to convert, but this would be a base of 3, so that becomes the base of the log, so log base 3 of the input of the log was the output, so 24 equals x now. And we would try to see what does that equal, and right now it's not going to be a pretty answer, so we can leave that if we need an exact form. But if I need to put this in my calculator, if I hit the log button, I got ln, hit it again, I got regular log, hit it a third time, now you get the log base option. So I want a log base 3 of 24. And I get an answer. So it's like 2.89, and it keeps going on forever. But if I need an exact answer, we just leave it like this. It doesn't simplify any further. Now some calculators have that base option. Some calculators do not. If yours does not have that base option, if you were trying to put in log base 3 of 24, you have to use what we call the change of base rule. So I would make that log of 24 over log of 3. And it's converted both of those to common logs, and every calculator will have a log, common log button. You could change that to a natural log. So if you wanted to do natural log of 24 or natural log of 3, that would be the same. So if I have room, natural log of 24, it's really hard to see, natural log of 3. So let me put that in here. So if I did natural log of 24 divided by natural log of 3, I still get the same decimal approximation. So those two things are equivalent. If I had done log of 24 divided by log of 3, we're still getting that same value. So that's your workaround if your calculator doesn't have the base option for you. All right, 3, if I convert, I'm doing log base e, so I'll write it this time, of 45, but know that whenever we have a log base e, that's going to be converted to a natural log. So I'm going to say natural log of 45 instead. And it's equal to x. We could put that into our calculator if we needed a decimal approximation, or we can leave it the way it is. So natural log of 45, ln of 45 is 3.81 if we round. And then in 4, we have a base of 10. It's a common log. So I'm going to say 10 to the 4th power equals x. This is something that we can find out nicely. So 10 to the 4th would have 4 zeros, so 1, 2, 3, 4. That's 10,000 if we simplified it. If you want to pause the video and try the rest of these, 5 through 12, you have enough that we could work through that on our own. So pause, try it on your own, and then you can play and we'll regroup. All right, if you already practiced these, this when I convert to exponential would say 3 to the 5th. Now 3 to the 5th is equal to x. 3 to the 5th we could put in our calculator or we could just work it out. But 3 to the 5th is 243. All right. Natural log is a log base e. So when I convert to exponential, this is a base of e and it's to the second power equals x. And that's about all I can do, because if I do e squared in my calculator, it's not going to be a pretty answer. You can do that. You just want to find your e button. So if I look underneath the log, we find e to the exponent button. So I'm going to hit that once, and it will do e to the exponent of 2 is 7.839 or 389. Let's do this one. I have 6 to the x power equals 36. So converting that really didn't help me any unless I know what x is. So 6 squared is 36, so I could just get x is going to be a 2 if I needed to solve that equation. But it depends on what the instructions say. So some might say just convert between exponential and logarithmic form. So if I just wanted it in exponential form, that's what this would be. If we wanted to solve the equation, then we could solve for x and get x equals 2. This, when it started out in logarithmic form, was already solved for x because x is by itself. So I could just put that in my calculator and find log base 6 of 36, and it would still say 2. Same here, x equals log base 5 of 5. It's already got x by itself, so if my goal was to solve for x, then I could just put in my calculator. If our goal is to convert, then I would start with our base of the exponent. Now this is a little bit backwards because the log is on the right, but the base is still 5, so I'd say 5 to some power equals. Now the input of the log became the output, and the output of the log became the input. So 5 to the x equals 5. That's enough to tell us that, oh, well, x would have to be 1, because 5 to the first power is 5. All right, 9. If I converted 12 to the x power is equal to 1. There's our exponential form. If we want to find out what is x, then 12 to what power is going to be 1? Well, it would have to be a 0, because anything to the 0 power will always equal 1. Number 10, it has a base of 10 because it's a common log, so I'd say 10 to the x power, because that's what it's equal to, would equal 10 to the 8. That's what's inside of the log. So even though it's got an exponent there, whatever was inside of the log became the output of our exponential. If I needed to solve for x, that would just be an 8, because 10 to the x is 10 to the 8. X has to be 8. And if we saw something like 11 and 12, we're going to do more of these in a later module. But to give us an idea of how to solve exponentials, we use converting to help us. So I'm going to convert this and say log base 4, because that was the base of the exponent of 100, equals x minus 3. That was the exponent. So if our goal was to solve for x, then I would just need to move the 3 to the other side. Right now it's in logarithmic form, so that's enough to get it in log form, but if I want to get x by itself, I'd add 3. Notice I'm not adding 3 inside the log because it wasn't an output. It wasn't 103, it was just 100. So 100 is the input of the log. We're just moving the 3 over to the other side so x is by itself. And that's something I could put in my calculator. Log base 4 of 100. Outside of the log, we put plus 3. And then we could get an approximation for it if we needed to. But x is by itself, so that would be how I solve for x. Number 12, because we have a base of e, we're going to use a natural log. Natural logs are already log base e of 16 equals x plus 5. So the in-between step, what happened from this conversion, I made this log base e of 16 and got x plus 5. But we don't write out log base e, we instead convert that to natural log. So natural log of 16 equals x plus 5. I would subtract 5 from the log, not from the 16, to get x by itself.